Welcome to this presentation which provides an introduction to the RealDWG's .NET API. My name is Balaji and I work with the Autodesk Developer Network supporting the platform technologies. This presentation was first created by my colleague Adam Naj in 2008 and this is an updated version of the presentation. First, let's have a look at the agenda for this presentation. We will start by clarifying what RealDWG is, and we will move on to discuss the differences between the .NET API for AutoCAD and that of RealDWG. We will then look at the steps to create a RealDWG application. I will use the sample created by Adam to explain the implementation. We will create an installer for it using Visual Studio and Windows Installer XML. And we will test the product and point out the importance of the various functions that we implemented. We will also show how you can reach the ObjectDBX COM API from RealDWG using objects like ACAD database, ACAD document and so on. At the end of this presentation, there will be a slide with useful links to places where you can find further help in using RealDWG and .NET. So what is RealDWG? RealDWG is basically an SDK with all its libraries which enables you to create, read and write DWG files from your application with 100% fidelity. It is not a viewer and cannot help provide visualization of the drawing. So if you want to visualize the DWG files, then you need to look into our other technologies such as AutoCAD OEM. RealDWG defines a framework which has no default implementation. By this, I mean that there is some basic functionality that you are required to implement for yourself before RealDWG will work for you. This is exactly how AutoCAD uses RealDWG. It does things like implement the RealDWG search functions to search for files in its support folder. You have to add similar functionality to your application. As I mentioned, the framework has no default implementation of these methods. In other words, the functions and properties of the host application services class that we need to override has no default implementation. If you want to make sure that your application is prepared for all possible scenarios, then you need to override the implementation of all these functions and properties. These methods and properties in .NET are just wrapper over the ObjectDBX C++ functions. So you can find more detailed description about these functions in the ObjectARX reference help file under ACDB host application services class. Also, RealDWG is independent of AutoCAD. So AutoCAD is not required on the machines where your application runs. The available APIs in RealDWG are C++ and .NET and also the AutoCAD ObjectDBX COM library. In this presentation, we will be focusing on the RealDWG .NET API. The following comparison between AutoCAD .NET API and the RealDWG's .NET API will only make sense to you if you are already familiar with the AutoCAD .NET API. If you are not, then it is worth taking the time to watch the DevTV on Introduction to AutoCAD .NET Programming. You can find it in the AutoCAD Developer Center. So what are the differences between these two APIs? As I mentioned, RealDWG is only for file database manipulation and the .NET API provides the same capabilities and way of usage as that of AutoCAD .NET API. As I said before, RealDWG does not have viewing functionality. Also, it has no user interface, no built-in functions to get user feedback or to create views for the drawing. So there is no API for such functionality either. Because this technology is completely independent of AutoCAD, you also cannot load ObjectARX, Lisp or VBA modules inside your application. Although a RealDWG application can load ObjectDBX or Object Enabler modules. This framework, the host application services class, declares many functions and properties which you need to implement. In case of writing an AutoCAD plugin, you would not need to care about implementing the methods and properties of host application services class because AutoCAD has already provided them for you. But you will be able to see all this for yourself through the sample application that we will demonstrate now. So let's look at a sample RealDWG application and go through the important steps. The first step is to add reference to the managed RealDWG DLL in your application. You can add the reference to this DLL from the RealDWG install folder. Second thing we need to do is add a class that implements the RealDWG framework. In other words, the class that implements the host application services functions and properties. Next, we need to import the namespaces that we need, such as database services and runtime. Now, derive the class from the host application services and implement the abstract methods and properties of this class. To find out more about the methods that we need to implement, use the object browser. To do that, open the class view and browse to the base class of your host application services class. Here we look for the find file and other methods and implement it. The other thing we need to do is to initialize the RealDWG runtime system. The best place to do that is inside the constructor of your class. The runtime system.initialize method requires two parameters. We need to pass in an instance of our class and the local ID which will be used, and in this case it's the default 1033. Another thing we need to do is to instantiate our implementation of the host application services class. So this will implicitly initialize the RealDWG runtime. When we run the program, we may encounter a file not found exception. What it is telling us is that during the initialization, there may be some file missing. If you look at the RealDWG documentation under known issues and limitations, we can get a clue from there. As the documentation is telling us, we need to add these three paths to the system's path environment variable. Also, we will need to redirect the output of our sample project to the RealDWG install folder. This will help our application to resolve the dependencies at runtime. The change to redirect the output to the RealDWG install folder is only required during your development. When your RealDWG application is deployed using an installer, all the dependencies will get resolved from the application's install location. Running your RealDWG application on a machine where RealDWG or AutoCAD is installed hides a couple of problems which you will face when running your application on a system when none of those are available. One of the problems is caused by not implementing the find file function properly. So this is vital. So what is find file about? As the name states, this function is here to find files which might be needed when loading various drawing files. These could be, for example, font files, object enablers, or other XREF drawings. We need to make sure that the application is able to locate all these files. Here is an implementation of the find file function. Let's go over it to see how it is implemented. As you can see, the method has three input parameters: the file name that the application is trying to find, the database we are in, and the hint about the file we are looking for. First, we find if the file name has an extension. If it does not, we use the hint to find the extension that we need to use. After we have the full path of the file that our application is trying to find, we just need some sort of search function. Let's look at our implementation of a search function. If we are already dealing with the full path, just return the file name. Next, we check the application folder and see if we find the file there. After that, we check if we have the ACAD environment variable and check if the file is located there. Next, we check the system path environment variable. As you probably know, these paths are separated by semicolons. So we try and find the file in each of those paths. Next thing is to check the system font folder, and after that we check the application's own fonts folder. And if we still did not find the file, we just pop a message box saying that the file was not found and which could cause RealDWG problems in its ability to correctly read the drawing. There are a couple of other functionality that we definitely need to implement in our host application services class. Your RealDWG application can slow down very much and also lead to errors if a font remains unresolved. In order to avoid that, the simplest way is to override the get property of the alternate font name. This should provide the name of the font which will definitely be installed as part of your application. So if the font used by the drawing is unresolved, this font will be used instead. As you can see in this implementation, it returns txt.shx, which we expect our installer will always install and will be found. Another thing we will need to look at, and which we will also see later on during installer creation, is in the redistribution requirement section of the documentation. For our application to have its own product specific section in the registry, we need to set the ODBX host app glow root and ODBX host app reg root values in the installer. If you also want to demand load other applications or object enablers, then we need to make sure that the registry section for our application can be found. The way to do that is by overriding the machine registry product root key and user registry product root key properties in our host class and provide the exact same path as that of the ODBX host app reg root in our product installer. Here we return the registry path, which for our application is software myRealDWG and 1.0. To make sure your application runs correctly, you need to make sure that your application implements all the methods and properties of the host application services class. For a more complete implementation, please have a look at the dump DWG C++ sample in the RealDWG SDK folder. Just to make it easier to understand the importance of each method and property of the host application services class, this sample project implements a debugger. The debugger helps control which functions are handled and to know what is going on in the application. So it is easy to point out the importance of the function we previously implemented in our host application services class. The whole point of this debugger class is to enable us to select which functions and properties we override and see its relevance. It also logs the input and output values of the functions and properties implemented by our class. This will let us see what is going on under the hood. This class contains a hash table which contains the functions and properties and lets us dynamically control which of them gets overridden and which are not overridden. The hash table gets populated with the methods and properties, and we also have a log function. Now let's look at the RealDWG functionality added to this program. The form has two buttons, Let's look at the functionality handled on click of each of these two buttons. In this case, we look for a drawing file in our My Documents folder, and if it exists, we then iterate through the entities in the model space and get the geometric extents of any text and raster image entities. If the drawing file does not exist, then we create a new drawing and insert a text and a raster image in it. So the way we do it is, we first get the path to the My Documents folder. We then look for the drawing in that folder. If the drawing already exists, we create a new database. In this case, we pass false as the first parameter, which is for building a default drawing. In this case, we do not want a default drawing since we will be loading an existing drawing file into the database. Next, we set the database as the working database. Before we do anything with the database, we need to start a transaction using the transaction manager. Using the transaction object, we can get to the object through the object ID. For example, first we get the block table and then get to the model space, which is a block table record. Once we have the model space, we iterate through the object IDs. We iterate through the object IDs of the entities in the model space. If the entity is a DB text or raster image, we get its geometric extents and display it using a message box. If the drawing does not exist, we will create a new database, but in this case we pass true as the first parameter. This is because we need a default drawing before we can add anything to a new database. Again, we are setting the database as the working database. We will then add a DB text and a raster image to the database. Finally, the database will be saved to a drawing file. In this sample project, we also demonstrate the use of the ObjectDBX ActiveX API. To use the ObjectDBX ActiveX API, we will first need an interop assembly that imports the ObjectDBX type library. Let me quickly demonstrate the steps to build the interop assembly from the ObjectDBX type library. I am running this on a 64-bit machine, so I will need a few additional parameters to TLB imp. First, open the Visual Studio command prompt. We will then change to the RealDWG install folder. We will use TLB imp to generate the interop assembly. Now the interop assembly has been created, and now you can reference the interop assembly axdblib.dll from the folder. Now let's look at the actual functionality added in this sample project using the ActiveX API. This is identical to what we did using the .NET API. That is, we add a DB text and a raster image using the ActiveX API. In this case, we get the ACAD database object from the database. We can then iterate the model space and find the geometric extents of any ACAD text and ACAD raster image that we find in the database. If the drawing does not exist, we create a new database. We set it as a working database, and then we get the ACAD database object from the database, and we add a ACAD text and a ACAD raster image to the model space. We then finally save the drawing. Now let's look at creating an installer for our product. In this presentation, I will be using Windows Installer XML or Wix. If you are new to Wix, it is worth taking the time to try creating a few installers using that technology. You can download the latest version of Wix from wixtoolset.org. After you install the Wix templates for Visual Studio, it should be possible to create Wix-based custom action, merge modules or setup projects from inside Visual Studio. After you install the Wix templates, you will find the several project types when creating a new project. Before we look at the custom action, merge module and setup projects that we have created for this sample application using Wix, let's look at the RealDWG specific requirements for creating an installer. Please refer to the RealDWG documentation under redistribution requirements section. Here you will find the names of all the merge modules that your installer will need to include. There are some required components and few optional components. For example, here are the required components and here are the optional components or merge modules that will be needed depending on what APIs your application is using. As an example, if your application uses the COM API, you will need these merge modules. Now that we have seen the list of the merge modules to be included, let's have a look at two simple batch files. These batch files copy all the files or merge modules required to be packaged to a common folder, which in this case is named as for packaging. This makes it easier to provide paths in our Wix source files because they are all in the same folder. So for example, first we copy the primary output, which in our case is our myrealdwg.exe. We then copy the interop assembly and the various merge modules. We then copy the merge modules required for COM automation support. We then copy the merge modules required for raster image support. And here are the Microsoft Visual C++ redistributables. The names of all these merge modules are listed in the RealDWG documentation under the redistribution requirements section. Let's first look at a simple custom action that we created using Wix. This displays a message when the installation begins. We will see later how this custom action is hooked to the installer. So this custom action provides a method that will display a message box when the installation starts. Now let's look at a merge module that we have created using Wix. It first defines the directory structure that we want on the target machine. We then add files to our installer package. And now let's look at the setup project. This setup project includes .NET Framework 4.5 as a precondition for the installer to run successfully. We then set up the directory structure that we want on the target machine. We then include the Microsoft redistributables. As you can see, all the file paths are from the common folder to which we copied all the files. Here is the primary output. In this case, it is the myrealdwg.exe. We then create merge modules. We then include all the RealDWG merge modules that were listed in the redistribution requirements. We then include all the fonts that we want for our application. And finally, we include the custom action that we have created. We are setting up the custom action to run before the installer begins. Now let's look at testing the application and its installer. To do this, I have a clean virtual machine with Windows 8 installed in it. I have copied the installer and let's run it. Here is the message box displayed from our custom action. Now our application is installed. Let's run the application and test the functionality. When I click on the .NET command button, it should create a drawing in the My Documents folder. So these are the methods and properties that were called when the drawing was created. In the Documents folder, you can find a new drawing that was created. And let's try the ActiveX command. And we also have another drawing that was created with a text and a raster image in it. To see if these drawings are okay, let's copy it to a system where I have AutoCAD installed. So our RealDWG application has inserted a text and a raster image correctly. So let's check the other drawing that was created using the ActiveX API. Here is the ACAD text and the ACAD raster image that was created using the COM API. Let's quickly review the steps for creating a RealDWG application. First, reference the RealDWG's acdbmgd.dll in your application from the RealDWG install folder. We then need to implement the host application services class functions and properties. We then initialize the RealDWG runtime system. We also need to set the database as the host application services working database. Make sure that the path system environment variable is properly set up with the 3 paths that are provided in the ObjectDBX documentation. And finally, build and test your application. Let's quickly review the steps for creating an installer. First, create a merge module. Include Visual Studio and RealDWG merge modules that are listed in the ObjectDBX documentation under redistribution requirements. Create a setup project and include your merge module and set ODBX host app glowroot and ODBX host app regroot in your installer. Here are some useful links about this topic. First is the link to the RealDWG Developer Center. Here you can find useful information on getting access to the RealDWG's SDK. The next is the link to the AutoCAD dev blog. This blog includes posts on AutoCAD.NET API and RealDWG. Finally, we have the discussion forums. We do not have a discussion forum specific to RealDWG, but you can post your queries to the AutoCAD.NET API forums if you have a query. So this brings us to the end of the presentation. Hope it was useful to you and found it interesting. I hope you have learned the basics to explore further into this technology. Have a nice day.